So next one, unit 3, free vibration. When elastic bodies such as a spring and a beam and a shaft are displaced from the equilibrium position by the application of the external force and then raised, they execute a vibratory motion. So this is due to the reason that when a body is displaced, the internal force in the form of elastics or strain energy are present in the body. At releases, this forces brings the body to its original position. When the body reaches the equilibrium position, the whole of the elastic or strain energy is converted into the kinetic energy, due to the which the body continues to move in the opposite direction. So the whole of the kinetic energy is again converted into the strain energy, due to which the body again returns to the equilibrium position. In this way, the vibratory motion is repeated indefinitely. So next to the term used in the vibratory motion, first one, the period of vibration of the time period. So it is the time interval after which the motion is repeated itself. The period of vibration is usually expressed in seconds. Next one is the cycle. So this is another one term used in the vibratory motion. It is the motion completed during one time period. The next one is the frequency. It is the number of cycles described in 1 seconds. In SI units, the frequency is expressed in Hertz, which is equal to 1 cycle per second. So next one, types of vibratory motion. The free or natural vibration, when no external force act on and after with giving its the initial displacement, then the body is said to be a free or natural vibration. The frequency of the free vibration is called free or natural frequency. Next one is the forced vibration. When the body vibrates under the influence of the external forces, then the body is said to be under forced vibration. So external force applied to the body is periodic disturbing force created by unbalance. Next one is the damped vibration. When there is a reduction in amplitude every cycle of vibration, the body motion is said to be a damped vibration. Next one is the types of free vibration. One is the longitudinal vibration, the second one is the transverse vibration, and third one is the torsional vibration. First we discuss about the longitudinal vibration. When the particles of the shaft or disc moves parallel to the axis of the shaft, then the vibration are known as the longitudinal vibration. In this case, the shaft is elongated and shortened alternatively, and thus the tensile and the compressive stresses are induced alternatively in the shaft. Next one is the transverse vibration. When the particles of the shaft or disc move approximately perpendicular to the axis of the shaft, then the vibration are known as the transverse vibration. In this case, the shaft is straight and bend alternatively, and bending stresses are induced in the shaft. The next one is the torsional vibration. When the particles of the shaft or disc move in the circle about the axis of the shaft, then the vibration are known as the torsional vibration. In this case, the shaft is twisted and untwisted alternatively, and the torsional shear stress are induced in the shafts. Next one is the natural frequency of the free longitudinal vibration. First one is these are the method used to find out the natural frequency of the vibration, longitudinal vibration. First one is the equilibrium method. In this equilibrium method, we have to equate the So this is the actual unstrained portion. When mass is added with the spring, there is a strained motion. From this, we have to identify the natural frequency of the system. So in this equilibrium method, that is, we have to equate the restoring forces and accelerating forces. So what is the restoring forces? That is W, that is minus h into h, and accelerating forces, that is mass into acceleration. And we have to equate these two things, equilibrium method. We have to find out to get the natural frequency of the system, that is omega equal to square root of s divided by m. The next one is the time period. The time period equal to Tp equal to 2 pi divided by omega, that is equal to the 2 pi into square root of m divided by s. From this we have to identify natural frequency Fn equal to 1 divided by 2 pi, that is 1 divided by 2 pi into square root of s by m. So next method is the energy method. The kinetic energy is due to the motion of the body, and the portion energy which is with respect to the certain datum portion which is equal to the amount required to move the body from the datum portion. This energy method we are considering the potential energy and the kinetic energy. So what is the kinetic energy stored in the body? This is half into m into dh divided by dt whole square, and the potential energy is half into h into h square. That is mean force into displacement. We have to equating this two. We have to get the omega equal to square root of s by m, and time period equal to 2 pi into square root of m divided by s. Next one is the radic method. In this method, the maximum kinetic energy at the mean position is equal to the potential energy at the extreme position. So when the so v equal to dx by dt, that is equal to omega into h. Maximum kinetic energy mean position is half into m into omega square into h square. Maximum potential at the extreme position is half into h into h square. So time period equal to 2 pi divided by square root of s by m, and the frequency equal to 1 pi to the above expression is known as a natural circular frequency and is denoted by the unit Fn.